Good day everyone, we are the Group 3 and today we will be presenting an exciting topic in the physics which is the shock waves, understanding the sonic booms, and supersonic flight. This topic is very interesting because it explains what happens when an object such as jet plane travels faster than the speed of sound. You might have already heard about the loud sonic boom produced by an aircraft, and today we will explain what causes the phenomenon and how shockwaves are formed. So first, let us understand what is shockwaves. So shockwaves are produced when an object moves faster than the speed of sound in air. Unlike normal sound waves, which spread out smoothly in all directions, shockwaves are different because the sound waves pile up and overlap, creating a sharp and powerful front. A very common example of these is an airplane moving at supersonic speed. At first, as it breaks the sound barrier, it produces a sonic boom that can be heard by people on the ground. Now, how do shockwaves form? When an airplane moves at supersonic speed, it compresses the air in front of it. Since the plane is moving faster than sound itself, the air doesn't have enough time to move out of the way. This results in overlapping sound waves that merge together, creating a cone-shaped shock wave, also known as the shock cone. The tip of the cone stays attached to the aircraft as long as it flies faster than the sound. Finally, how do we experience shock waves? Of course, when the shock cone passes over an observer on the ground, it is heard as a loud boom. This is a sonic boom. It's not just a single explosion-like sound, it's the continuous effect of the plane moving supersonically and the shock wave passing by. So in short, shock waves are a direction result of an object moving faster than the sound, compressing air in front of them and producing a sharp and powerful sound effect that we call a sonic boom.
Good day everyone, I'll proceed by explaining the Mach number. The Mach number, written as capital M, is the ratio between how fast an object moves and the speed of sound. So it helps us understand if something is slower, equal to, or faster than sound. The formula is m equals v divided by vs, where v is the speed of the object, vs is the speed of sound. When the Mach number is 1, ang object is moving at the speed of sound. So this is called sound barrier. If the Mach number is greater than 1, the object is flying at supersonic speed. So at this point, shock waves and sonic booms can occur. And as the number of Mach increases or magtaas, ang angle sa shock waves behind ato nga object becomes smaller. So that means that if it goes faster, the sharper and thinner the shock cone becomes. So here we have a famous example, which is the Bell X-1 airplane, which Chuck Yeager piloted in 1947. So he was the first person to fly faster than sound, which officially breaks the sound barrier. Next, let's proceed to the geometry of shock waves. So when a plane travels faster than sound, mag-create siya og shock wave. So this is a cone-shaped wave trailing behind sa aircraft. So the size of that cone is measured by its half angle, shown here as the Greek letter alpha. We can calculate it with the formula sine of alpha equals the speed of sound divided by the speed of the source. So in the formula, v is the speed of sound while vs is the speed of the airplane. We can also write it as sine of alpha equals 1 over the Mach number. So this means that ang cone size depende on how large the Mach number is. As the Mach number increases, meaning ang plane mas faster siya ga-fly, and ang cone behind it becomes narrower. So that's why ang kanang mga paspas nga jets have sharp o thin nga shock cones. So that is for the geometry of shock waves. So now let's proceed to the next slide.
Hello everyone, good day. So now let's start by talking about sonic booms. So a sonic boom happens when an aircraft flies faster than the speed of sound, which we call supersonic speed. As the plane moves, it creates pressure waves in the air. It's kind of like the ripples you see when a boat moves through water. So when the aircraft goes supersonic, these pressures waves build up and merge into a single powerful shock wave. So when this shockwave passes an observer on the ground, it causes a sudden pressure change. So that's what we hear as a loud, explosive noise known as a sonic boom. So it's important to note that a sonic boom isn't just a single bang at the moment the plane breaks the sound barrier. It actually continues as long as the aircraft remains supersonic, so the boom can follow the plane across the sky. So the effects of a sonic boom can be dramatic. It can rattle windows, make objects vibrate, and create loud disturbances that can startle people or even cause minor damage. So the image on the left shows the shockwave pattern forming around a supersonic aircraft, while the photo on the right captures the moment a jet creates a visible condensation cloud as it nears the speed of sound. So now let's proceed to caution and applications. So because sonic booms can be so disruptive, no? So there are important cautions to consider. So these booms can disturb entire communities and in some cases even cause minor structural damage to buildings. So for this reason, supersonic flight is heavily restricted over land in many countries. So commercial planes are generally not allowed to break the sound barrier over populated areas because of the noise and potential damage. However, there are also valuable applications of supersonic technology. Military aviation regularly use supersonic jets to achieve high speeds during missions. So high-speed experimental jets and research aircraft also rely on breaking the sound barrier for testing and innovation. In addition, engineers and scientists are actively working on research to develop future supersonic travel that's quieter and safer, though sometimes called low boom technology, so that someday might have passenger flights that can cross oceans with much faster without disturbing people on the ground. So while sonic booms present challenges, they also drive advancements in aviation and technology. And that will be all. Good day.
So to wrap things up, I'll be walking you through a sample problem that demonstrates the physics behind supersonic flight. So first, let's look at this problem. A plane flying at Mach 1.75 where the speed of sound is 320 meters per second. So to find the plane's speed, we multiply the Mach number by the speed of sound. This gives us the 560 meters per second. Next, we find the angle of the shockwave cone. This angle alpha is calculated by the inverse sine of 1 divided by the Mach number. So the inverse sine of 1 divided by 1.75 give us about 35 degrees. So this angle of the cone-shaped pressure wave that creates a sonic boom. And finally, in conclusion, shockwaves are created when an object travels faster than sound, creating a sharp pressure front. And the Mach number helps us to understand how fast an aircraft is moving compared to sound. And sonic booms are a powerful sign of supersonic flight. That's all. Thank you.